Assalamualaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children, we are going to start a new chapter today, understanding quadrilateral. Okay, so let's begin the chapter. So this is polygon. So have you heard about this word polygons? So this is like a simple, see, first of all let's look at the simple things over here. It says a simple closed curve made up of only line segment is called as polygon. So if you have a simple curve, so what I mean by the simple curve is like you just join okay, this is one of the simple curve. Okay, you don't have any twists over here, right? So this is simple curve. Now if I do something like this is not a simple curve. Okay, so this one is a simple curve, this is not a simple curve. So similarly this is with the curved surface, right? It's like a curved this is a curvical line. Now if I have a straight line, let's say like this. Okay, so this is also a simple curve with line segments, not the curved line, but you have a straight lines, right? Now if you have something like this, then this is not a simple curve. Okay, so this is one, it's a simple curve. So they are saying a simple closed curve, so it should also be a closed one. Okay, it should be a closed figure, it should not be left out like this. This is not a closed curve. Okay, so a simple closed curve made up of only line segment is called as polygon. So now here you see this one, it's like a, you have a simple curve. This is a closed figure and it's with only with the line segment. This is also a closed figure with a line segment. This is also a simple closed figure with a line segment. So these are polygons. Now here you see, look at this one, these are not polygons. See, this is open over here, and here it's like this is not a simple curve at all. Here also this is open over here, right? So this is not a simple curve, so this is not a polygon. Okay, now let's look at the classification of polygons, like what all kind of polygons are there. So we classify polygons according to the number of sides. So the name to the polygon is given based on the number of sides it has or number of vertices. Vertices means these are called as the vertices. This corners, these like in a triangle there are 3 vertices. Okay, 1, 2, 3, these are the vertices. Okay, so now here when you have 3 sides, it's called as triangle. Tri for 3. Okay, and we all are familiar with triangle. Okay, then the 4-sided figure is called as quadrilateral. So any 4-sided figure, see, even our square, rectangle, parallelogram, all these things, any kind of 4-sided figure is going to be a quadri. It comes under quadrilateral. Okay, now 5-sided figure is called as pentagon. So penta means 5. Okay, and quadra means 4. All right, tri means 3. So the pentagon is like 5-sided figure. See, like in this case 1, 2, 3, 4 and 5. Hexa goes for 6. Okay, hexagon. So 6-sided figure, and 7-sided figure is called as heptagon. Okay, so hepta goes for 7, and 8 goes for octagon, and 9 goes for nanogon, and 10 goes for decagon. Okay, so now these are the figures. Okay, the number of sides. So based on the number of sides you have been classified the polygon. Okay, now based on the diagonal, see a diagonal. So first you should know what a diagonal is. Okay, so when you have a figure, the crossly joined line, crossly joined point, see, a diagonal is a line segment connecting two non-consecutive vertices of a polygon. When I say consecutive, this means the next to next. Okay, the one closer to you. Okay, let us say there is like A, B, C, D. Now when I say consecutive, so let us say these are 4 positions, 4 girls are sitting in an order. Now this A and B are like consecutive, see, because they are sitting closer to each other, but A and C are non-consecutive. Understood? Similarly B and C are consecutive, and C and D are consecutive. Okay, so the next and next one are consecutive. Now the alternate ones are, the A and D are non-consecutive, B and D are non-consecutive. Similarly A and C are non-consecutive. So the points, when it comes to points, like if I talk about this, see, this point is closer to this point, and there's this point also. So these two are consecutive. For this point, this and this are consecutive points. This is the only point which is non-consecutive because it's not closer to that, right? So these non-consecutive, so the line joining the non-consecutive points, so this and this is called as a diagonal. Okay, similarly for this and this will be called as the diagonal. So here for this you see this dotted lines. For rectangle, these dotted lines are the diagonals. For this figure 4.1, I mean this one, pentagon, see how many number of diagonals are there, right? And here you see you're in a rectangle. Okay, let me talk about a triangle. Triangle, you can't draw a diagonal in case of a triangle at all, because see, both the points are, all the points are consecutive to each other, so there is no diagonal drawn for a triangle. Okay, so there is a formula to find out the number of diagonals in a polygon. So this is the formula. N goes for the number of sides. Okay, so number of diagonals will be n into n minus 3 by 2. N is the number of sides. So like for example, here for the first figure is 4 sided, right? So let's put n equals to 4 and check. Okay, so 4 into 4 minus 3 by 2. So 4 into 4 minus 3 is just 1 by 2. 2 ones are 2, 2 twos are 4. So there will be 2 diagonals. Okay, similarly for triangle, you see, triangle has 3 sides, so 3 into 3 minus 3 by 2. 3 minus 3 is 0. So 3 into 0 by 2 is going to give you 0. Anything multiplied by 0 is going to be 0. So there are no diagonals at all. Now coming to this one, how many sides are there? 1, 2, 3, 4, 5, right? So n equals to 5. So let's do 5 into 5 minus 3 by 2, which is 5 into 2 by 2. So the 2 gets cancelled and you will get 5 diagonals again. So let us check how many diagonals are there. This is 1. Okay, you're supposed to get 5 diagonals. Let us check on the figure. This is 1. Then the next diagonal, let me draw with a different color. 2. Then the next diagonal I'll draw with a different color. 3. And then you have 4. And then you have 5. So see, you have got 5 diagonals, right? So that's how you get it. Okay, now come to the next one. Yeah, and in this figure, the last one, see, there are how many sides? 1, 2, 3, 4 sides, right? So again, you're supposed to get 2 diagonals. And look at the dotted lines. So the dotted lines are what are called the diagonals. Okay, this is one diagonal and this is one diagonal. So 2 diagonals. Okay, now convex and concave polygons. So when I say convex, so it's a figure. See, if I talk about a shape like this, okay, see, this side is called as convex. Okay, all right, so this side is called as convex. Here you see, you know, it's like you know, you talk about a spoon. Let us talk about a spoon. Okay, so I'll explain what is convex. Okay, let's talk about a spoon. This part of a spoon, the down part which is curved outside, is called as the convex part. Okay, the inside where like you have a scoop, no, like a cave, right? So that kind of a shape is called as concave, because it's like going inside, right? It's like a concave figure. Okay, so you understand what a convex is and what a concave is, right? So now here, the polygon which has only convex sides outside, when you look at it, if it has a bouncing, like, you know, a protruding end like this, see, these are all convex. They are facing, coming out. No, it's not like a cave. See, all of them are having a outside figure, right? So you can have a flat figure, that is fine, that's not taken into account. Only the other ones apart from the flat surface, see, you should have a things which is coming out. It's not like inside going inside, right? So all these are concave convex polygons. Okay, because you don't have a cave like structure over here. But look at the second thing. In the second thing, you have things which are going inside. See, here it's like a cave, no, it's going like this. Here also, see, it's like a cave going inside. Here also. So these are called as concave figures. Okay, so you understand the meaning of convex and concave. All right, now come to regular and irregular polygons. So you know that polygons means you have many sides, right? And based on the number of sides, you have given names to it, right? Now if the polygons, like, you know, let us say you have 4-sided figure, for example. Okay, if the 4 sides are equal, then it will be called as regular polygon. Okay, if I talk about a 5-sided polygon like a pentagon, and if the pentagon, you know, has all the 5 sides equal to each other, then it will be called as regular pentagon. Okay, so if you have different sides, like, you know, if all the 5 sides or all the given sides are not equal to each other, then it's called as irregular. Okay, see, in this case they have given, see, when they draw a line over here like this, this means that, you know, all these things are equal to each other. So when all these are equal, all the sides are equal, all the angles will also be equal. See, these angles will be equal to each other. Do you get it? So this shape for the angles, when you draw a same shape for all of them, it means that they are equal to each other. So a regular polygon has all sides equal and all angles also equal. Okay, so you can call that equilateral triangle. You'd have heard about it, right? So when you have all the sides equal, you call it as equilateral. If it's a triangle, you call it as equilateral triangle. If it is a pentagon like this, you'll be calling it as equilateral pentagon. Okay, so and also not only equilateral, they have equal angles also, so it's equiangular also. So a regular polygon is both equiangular and equilateral. Understood? Now if you look at this 1 2 3 4 5 6, so this is a hexagon. Okay, so this hexagon has got all 6 sides equal to each other, all 6 angles also equal to each other. So this is a equiangular or equilateral hexagon. Okay, now here you look at it, they have just drawn the lines over here. These two are equal to each other, the others are not equal, right? Then you can say that this and this are equal, but this has got a different shape, size. Okay, so they all 5 are not same, so they are not regular, or you can call it as irregular. Here you see these 2 sides are equal to each other, I mean these 4 sides are equal, and this are separately equal, right? So here you see these 4 angles are equal to each other, but the other 2 angles are again separately equal to each other, so they are irregular polygons. Okay, so regular means all of them has to be equal. Okay, now angle sum property. So you people are familiar with angle sum property of a triangle. So if it is a triangle, if 3 angles are there, you know that you are supposed to add up, or all the 3 angles add up to 180, right? So here similarly, for sum of quadrilateral, see if you have a quadrilateral, as I told you, quadrilateral is just a 4-sided figure, right? So let's draw a 4-sided figure. Now here if I divide this into 2, just join the diagonals, I get 2 triangles, right? On top I get 1 triangle, here I get one other triangle, and I know that the angles in a triangle always add up to 180. So here I get 180 degrees separately, here I get 180 degrees separately. So total angles added together will be, you add 180 plus 180, which is equals to 360 degrees. So angles of the sum of a quadrilateral, sum of angles of a quadrilateral, okay, let me say angles, okay, of quadrilateral is 360 degree. All right, now so what if you have many sides? Okay, so you can actually draw a side, let's say like you draw a pentagon for example. Okay, so you can divide it into 2 triangles, right? 1 2 3 triangles, right? You have got 3 triangles, so this is going to be 180 plus 180 plus 180. So all 3 sides added together is going to give you how much? 540, right? 540 degrees. Okay, so this is what you're getting, but then it's very difficult to sit and add this, so you have a regular formula for this, 180 into n minus 2. So this formula you can use to find the number of angles, sum of angles in a polygon. Okay, let it be regular or irregular, that doesn't matter. Like in case of a pentagon, we know that n is 5, right? So let's just see if you're getting 540. You actually got 540, right? So let's see if you get 540 using the formula. So 180 into n minus n is 5 minus 2, so it's n 180 into 3, which is actually 540. Understood? Okay, so that's it. Okay, so now see here I have given you one example. What is the sum of angles of an octagon? So you should know octagon has 8 sides, so it's going to be 180 into 8 minus 2, because n is 8 over here, so it's 180 into 6, and that's going to be this much. Okay, so you can check it, you can solve this and check it. Now come to exercise 4.1. we are just going to randomly pick few problems and solve it, and then in your classwork, in your geometry classwork, you are going to complete this exercise 4.1. okay, so find the angle measure x in the following figure. So you have to find this. So you know that this is a quadrilateral. So quadrilateral has how many, what will be the sum of all the angles? It will be 360. So 130 plus 120 plus 50 plus x is going to be equals to 360. So you add all of them, so that's going to give you 300 plus x is equals to 360, or x is equals to 360 minus 300, which is 60 degrees. Okay, now similarly in this case, see, you have to find out what is x, but you don't have all the angles, interior angles, so find this angle and this angle. Okay, So you can use the linear pair formula. See, it lies on a straight line, so this whole thing should be equals to 180. So this thing is 70, so the remaining has to be 180 minus 70, which is 110. So this is actually 110 degrees. Similarly, 180 minus 60 over here, so this is going to be equals to 120 degrees. Okay, so adding 120 plus 1 at 110 plus x and one more x plus 30 is going to give you how much it is supposed to. So you should find out how much it is supposed to add and give you, right? So it is 1 2 3 4 5. So there are 5 sides in this, so sum of angle of 5-sided figure, it's going to be 540. So all the angles inside should add up to 540. So 110 plus 120 plus 30 plus there are 2 x's should add up to 540. So that's giving you 260 plus 2x is equals to 540. So 2x is equals to 540 minus 260, which is 280. That's it. Okay, so now then you know this 2x. Okay, but we need to find x, right? So you'll have to divide it by 2. So that's going to give you 140. Okay, so now come to the next question, question B of this particular question. See here, they are asking you to find x plus y plus z plus w, right? So here you see you have a quadrilateral again, and they are asking you to add all the exterior angles. See, the angles inside the quadrilateral are called as interior angles, and the angles which are outside are called as exterior angles. So x, y, w, z, all these 4 angles are exterior angles. So you find out each angle. Okay, so the x is actually 180 minus 120, which is 60. Y is 180 minus 80, which is 100. Z is 180 minus 60, which is 120, right? So each angle you have to find out. This is 180 minus 100, which is 80. Now add all these exterior angles. So 120 plus 80 plus 60, and there is, okay, here, wait a minute. Yeah, so first you need to find out A, right? Because only then you can find the W. So for A, you find out using all these 4 angles, 120, 180 plus 60, and then A gives you 360. It is supposed to give you 360 degrees, right? So when you add this, you know, you get 260 plus A equals 360, or A equals to 100 degrees. Okay, so first using the interior angles, you find the A. Then you use this A to find the W. Then add all of them and you get 360 degrees. Okay. And then so exercise 4.1 in geometry classwork, that's your homework for today. Okay, so inshallah I'll see you in the next video. Allah Hafiz. Thank you.